To start this lesson, we're going to do a quick recap of the different types of quadratic relations or parabolic relations that we studied. Now, the first form that we saw was this. This was called the standard form. Now, the standard form looks like this, where we have y equals ax squared plus bx plus c, where c, the c value, represents the y-intercept. And the point for such a thing is of the form 0, c. An example would be this. Y is equal to 3x squared plus 2x minus 6. In this case, the y-intercept is -6, and the point that's represented by it on a graph would be 0, -6. Now, that was the first form. The second form we looked at for a parabola is something that looks like this. And we call this the vertex form, where h and k represents the vertex hk of our parabola. Now, for an example would be y is equal to -3 x plus 4 all squared plus 5. In this case, our vertex is going to be the opposite of what's inside the bracket for 4. We call that opposite world. And plus 5. And now, let's take a look at our final type of parabola. Our final type of parabola is going to be, and the third form is called the intercept or factored form. Now, these intercepts are basically talking about the x-intercepts. And we use this in conjunction with our factoring. So with factoring, we normally get our with factoring based on this first equation type here, we get this equation here. And with this factoring, you get these things called roots, otherwise known as zeros. And in this case, our zeros are s and t. Now this tells us that our points are given by the values s0 and t0. And we're done. So for today's lesson, what we're going to do is we're going to solve all these problems using quadratic relations, also known as parabolas. Now this equation, 2x squared plus 4x minus 6, we call the standard form. Now they've asked us to graph this parabola, but then also show the zeros and the axis of symmetry. But we know that from the standard form we have this thing called -6 at the end, and that -6 represents the initial value, or the y-intercept. Now, the representation of the y-intercept in this case is -6, which means we have a point 0, -6 on our graph. So I'm going to quickly graph that here. 0, -6. Now, from last day, we took a look at a thing called the intercept form. Now, remember, the intercept form was basically another term for factoring the standard form. Now, when we factor the standard form for y equals x squared plus 4x minus 6, we get the following. And the first thing that we're going to do is we're going to pull off the 2 that's sitting on the x squared, and we end up with 2 times this bit here. Now let's identify 3, the negative 3. The negative 3 has factors of 1 and 3. So now we'll break our y equals 2, and then we have a first bracket and a second bracket. We have x, well, and a 3, and then an x and a 1. Now, we have to take those 2 points, 3 and 1, and we have to add to the center term. So we have to have plus 3 and minus 1 as our factored form, otherwise known as intercept form. Okay, so just remember, this forms the intercept form. So when we factor, we're just literally finding the intercept form. Now, when we find the intercept form, we're actually talking about the x intercepts. So in this case, we have this new concept called zeros. So when we have our zeros, if we take a look at this first bracket, our first 0 is negative 3. So think about that bracket. What value of x makes that entire bracket 0? So we have negative 3. And for this second bracket, we have y is equal to 1. So this means we have points for our x-intercepts to be negative 3, 0, and 1, 0. Now let's graph those points on our graph over to our right here. So we have negative 3, 0, and 1, 0. Now, you know that for every quadratic, which was a parabola, our parabola always had something that took our parabola and split it in two. And you'll notice that it always went, whatever that thing was, that mirror line, otherwise known as the axis of symmetry. Okay? The axis of symmetry always went through the vertex. And that was always the x value of the vertex. Now imagine if I had put this on a graph. That means that these 2 points, this one and this one, were exactly the same distance across from the axis of symmetry here. Now, in order to get the number that was in between those two, all we have to do is average. So let's do that. For part B, it asks us, what is the axis of symmetry, also known as the AOS? So in order to do that, we'll just write this equation. Now for the axis of symmetry, we always have to add 2 numbers. And just like I said before, when we were looking at our parabola, we had 2 points that were equal distance from this center point, this center line. So what we're actually doing is find the average between these 2 points. So the average between those 2 points are given by taking the minus 3 that we had before and the 1 that we had before and putting them here and here. So now we have minus 3 plus 1, which equals negative 2 over 2, which equals negative 1. Therefore, the axis of symmetry is x equals 1. So what we're going to do is we're going to take that x equals 1 and draw a vertical dashed line that goes down the center of our graph. So there is our dashed line that goes through there. And then what we're going to do is we write x equals -1. Now that, remember, is the axis of symmetry, which shares the same x value of our vertex for our parabola. So now, remember this point that we had here? So if you remember, we had a point that we had right here. So our matching point is going to be over on this side of our graph. And if you take a look, our original graph was 2, which means our original graph for y equals 2x squared plus 4x minus 6, the a value was equal to 2, which means it's going up. So that means our graph looks like this. And goes somewhere through here. We don't know what our y value is, but we'll find that at some point. Now, I'm going to start you on question 1b, and then we'll graph. You're going to do the rest, and I'll show you the solution. The first thing you'll see is your y-intercept is 2.5. So remember, when we use our intercept form, it means that we have to factor it. So we have this portion for our first bit of factoring. Then we have to break the bracket up. And we have 1 times 5 as our final number that we're finding. The combination of 1 and 5 that gives us -4 is -5 and 1. So that's what we get. From here, our zeros are 5 and -1, which means our points are 5, 0 and -1, 0. So we have our 2 points graphed here. Now, if you take a look at the a value on our original graph, this means it's opening down. Now let's go and calculate our axis of symmetry for our parabola. That is part 2b. And so now we have x is 2. So let's go and plot our point. Let's go and plot our axis of symmetry. So we have this dashed line, and we're going to call it x is equal to 2. So now, remember, if we have our first point on our y-axis, our other point is going to be right about there. We said the parabola was opening down, so our parabola looks something like this. And we're done. So now, our next problem set, question number 3, requires us to find the equation of the axis of symmetry. Axis of symmetry for each relation, and then we're going to find the vertex, and then we're going to find the vertex form based on that. So basically what we need is the axis of symmetry, and that really means we need the intercept form, which means we need to factor first. So let's do that for this first problem here. Y equals x squared plus 16x plus 55. So now let's go over our zeros. Our zeros for each bracket are given by, for the first bracket, we're going to have -5. And for the second bracket, we're going to have -11. Which means our points for the first one, -5 is -5, 0. And for the second one, it's -11, 0. So remember, we have to now calculate the vertex. So in order to calculate the vertex, we have 2 things we have to do. So you're going to leave yourself space for 2 calculations. The first calculation is the axis of symmetry. So remember, the axis of symmetry basically makes us take two numbers, adds them, and divide by 2. Those two numbers are going to be -5 from our zeros and -11 from our zeros. And this simplifies to this. X equals -16/2. And we end up with x is equal to -8. Now I'm going to put a bubble around this to represent the x value of my y, of my vertex. The second calculation is if x is equal to -8. We are actually plugging that into our original equation. Y is equal to, well, x plus 5 and x plus 11. And we end up with this -8 plus 5, -8 plus 11. And you're going to end up with, for the first bracket, -3, second bracket, +3, which means y is equal to -9. Which means our vertex is -8 and -9. And remember that we had to have our vertex form. So the last part we need for our vertex form is this a value. The a value on the x squared term is just equal to 1. And we end up with our vertex form being y is equal to 1, which was our a value. X plus 8 squared, remember it's opposite the negative sign on our vertex. And then -9. So now let's work on this second problem that we have here. So the intercept form, I'll give you this for this graph. So we have y is equal to -4x, x minus 6. The zeros are tricky for this one. For this part of our graph, the first part, the zero is actually 0. And for the second part of this graph, we've got +6. And we have these for our points. Now, go and do the vertex calculations and find the vertex form. Pause the video and then see if your solution matches mine. So just like before, our axis of symmetry was calculated the same, but this time, instead of using our factored form, you could use the original. -4x squared plus 24x, and just substitute what we know. So we end up with y is equal to -4 times 9 plus 24 times 3, which is 72. And this ends y is equal to -36 plus 72, which means y is equal to 36. So I'm going to put my y is 36 in a box here, and now we can state what our vertex is. Our vertex is 36, and our vertex form is y is equal to -4 because our original a value was -4, x minus 3 because the original x value is always swapped inside this bracket to be the opposite, and then we have plus 36. So for this next problem, we have to consider the standard equation. Now, in the standard equation, the first thing that we can identify is the y-intercept. So for this point, we can find that its value is 0 to 60. So the next thing we have to do is we have to take a look at the graph that we have to do for this one. So they've asked us to kind of graph it. So here's my first point, 0 to 60. I'll just put that on my graph there. This is my y-axis and this is my x-axis. So now that we have all that kind of organized, it asks us if we have a maximum or a minimum. So when we have a maximum, we have something that looks like this, and for a minimum we have something that looks like this for our parabola. So if I take a look at the original equation, y equals 4x squared minus 72x plus 60, the a value is 4, which means our parabola opens up. So ours is the first circled value, which means in this case we're finding a maximum. Now, when we're looking for a maximum, we're actually trying to find the y value or the minimum. Okay, so let's find the maximum or the minimum. So let's do solution B. So anytime they ask us to find the maximum or minimum, they're asking us to first factor our equation, and then we need to find the AOS, and then we need to find just the y value. And that is the key. When we get to this, that is our max or our min. And so now our zeros are 13, 0, and 5, 0. So what we're going to do is we're just quickly going to make sure that we kind of sketch where we think they're going to be on our graph. So here's 13, 0, and here is 5, 0. Now, remember, we have to do our vertex calculation like before. So just like before, we calculated our AOS to be 13 and 5, which means our x value is going to be 9 in the end. So now, let's calculate the next part. So remember, we always had to calculate if x equals 9. We're going to substitute back into our original equation or our factored form. I'm going to sub into my factored form. And this is what you get. Substituting in, you end up with y is negative 64. So this means our axis of symmetry is somewhere in here. And it's x equals 9. And our vertex is at somewhere along this line, with the x portion of our vertex being 9 and the y value of our vertex being negative 64. And so when we graph our parabola, we have something that looks like this. And we're done. So now, if I wanted to, I could say, so the vertex is 9, negative 64, which means that our vertex form is y is equal to 4 from our original value. Our a value was 4. X something squared, and instead of positive 9, it's going to be minus 9, and then minus 64. And we're done. So take a moment, write that down, and then pause the video, and then move on to the last problem of the day. So this problem here says right away to start that our zeros are at 1 and negative 1. So let's actually write that down. So if I have my zeros are negative 1 and positive 11, okay, that means the points are negative 1, 0, and 11, 0. So we're just practicing how we would find our points on a graph. Now, that tells us right away what our intercept form is. The intercept form comes from the zeros. So, what you do is you start with y is equal to a, and then you write x, and now remember our original 0 was minus 1. So, instead of minus 1, we're going to put plus 1 here. So this matches with this, but we're using opposite world. And then the other bracket is going to be, well, x minus 11. So they've given us that information, but now what they've said is, they've said that our point passes through the point x, y, which is from 3, 8. So what we're going to do is we're going to substitute those in. So we get 8 is equal to a bracket 3 wherever x is. And now we simplify. Now we have a times 4 minus 8, which gives us this. 8 is equal to minus 32a. So now in order to get a by itself, we have to divide both sides by 32, and we end up with our a value equaling 8 over negative 32. Which means that a is negative 0.25, which equals to a. Now remember, they asked us to state what this equation was in intercept form. So the intercept form is going to be y is equal to negative 0.25, and then we use our x plus 1, x minus 11 from before. And now we can go and do the vertex form type calculation that we did before. Just copy the information down on the screen that I post right now. And now just for the vertex form, we do exactly what we did before. We identify the vertex and then we go and just state our basic equation using the a value from the intercept form. Now finally, you'll see that when we talk about the final standard form, we can either expand the vertex form or we can expand the intercept form, and we're done. Now, your homework is based on these questions. Remember that your test is in 2 days.